Well, to my disappointment and in a sense my relief, yeah, I don't have to be such a rebel, okay, because I made some error, okay, so yeah, I didn't quite disprove Fermat's theorem. I didn't disprove Bill's conjecture, okay, Mr. Bill's conjecture. Okay, good. So let's move on, okay, so 10a plus 1 to the fourth. Pascal's triangle, okay, so plus 1, okay, so let me get some terms. I'm having heartburn. Alright, my heart is burning. Burning heart. Heartburn, whatever. Okay. 10 plus 1 to the fourth. Okay, so 4,000 a cube plus 600 a squared plus 40a plus 1. Okay, so that's that. Now we have 10b plus 5 to the fourth. Well, you play smart, okay? It's 5 to the fourth, 2b plus 1 to the fourth, okay? It's what? 25 times 25 is 625, right? I know that shit, right? 6 to be fourth plus 4 times 8, 32. 6 times 4b squared, 24. 4 times 2b, 8b. 1. Okay, so. Okay? Which is equal to um, I'm not gonna multiply this fuck, okay, so no. 5 to the fifth, okay. 5 to the fourth times 2 to the fourth times b to the fourth, okay, plus 5 to the fourth. My goodness, what the fuck did I do? All this for nothing. To the fifth, b to the third plus 5 to the fourth times 3 times 2 to the third, okay, 24, okay, 8 times, 3 times 8, okay, b to the second plus 5 to the fourth times 2 to the third, b plus 5 to the fourth, okay, so, whatever. And we add them fucking together, alright? That's the left hand side, okay, so we add them together. This guy and this motherfucker, okay, so. I don't wanna do this shit. But we'll have to, alright, so. If we, let's say, call this left hand side, no, this number one, number two, okay. If we add number one plus number two, that's the left hand side, okay. So that's the left hand side, all right. If you add them together, oh my goodness. Okay, before we do that, let's simplify the left hand, I mean number one. Okay, and number one is equal to 10 to the fourth, a to the fourth, okay, plus 4 times 10 to the third, a to the third, plus 6 times 10 to the second, a to the second, plus 4 times 10 to the fourth, a to the fourth, plus 1, okay, so that's binomial expansion, okay, so. Alright, so this guy is number 2, right? So number 1, left hand side is equal to number 1 plus number 2. We have to factor it out correctly, okay, so. Alright. So 10 to the fourth, which is 5 to the fourth times 2 to the fourth, okay, so. Adding this together, okay, so that's a to the fourth plus b to the fourth. Second term. Really. Okay, 4,000 is 2 to the third times 5 to the third times 2 to the second, okay, so that's 4,000, okay, so we factor that, okay. What the hell am I doing? Common denominator, kind of, okay, so, okay, 5 to the third times 2 to the fifth, right? Okay. Okay. Good. That's what I meant to say. Now this guy. It's not easy, alright? So you have 2 to the second and 5 to the second, and then you 2 times 3 downstairs. Okay, so that's what, 2 to the third times 3 times 5 to the second. Okay, so factor it out. What a nightmare. Okay, 2 to the third, and then 3, and 5 to the second, and you have 25 b squared plus a squared. Okay, all right. We'll review this. Okay, if you are not following, don't worry. Okay, we'll review this. I'm in pain too. Okay, it's not easy for me. Okay. All right. So you got that. This left hand side. Okay. So right hand side. What the hell do we have? I have to look up. Oh my goodness. So that's left hand side. Okay. On the right hand side, we have 10d plus 6. Okay. So okay. Right hand side. Well, let's use different color. Okay. So right hand side, we have 10d plus 6. Okay, so can you find some d that makes left hand side and right hand side is equal? Okay, well, we'll see. I mean, this is same as 5 times 2d plus 1 plus 1, right? So, okay. We do use the same methodology. Can you find some D? 1, 1, subtract. Fine. Okay. So can you find some D where 2D plus 1 is equal to divide by 5? Okay, so A and B, yeah, they can be 1. Okay, 1 or more, doesn't matter, right? Okay. 2 times 10 to the third, okay, A4 plus 4 times, I mean, 2 times, we're dividing by 5, right? Subtract 1, divide by 5, okay. From here, right? From right there, okay, so, okay. 10 split it out, divide by 5, so the 2 is left over, okay, so, right there, okay. Divide by 5, so 5 to the second, 2 to the 5. I was looking forward to it. 5, 2 to 5, yeah, I was looking forward to that. We may still be able to disprove Fermat's theorem, okay, so it's possible because, I mean, we are not happy about it, but I think it's still possible, okay, so, alright. Or we may prove it, disprove it, we don't know yet. We just need more space. We're gonna take another whiteboard, okay, so, okay? We'll take 5 minutes break. I don't know where this is going, I don't know. We may prove it, disprove it, I don't know. But we are curious. Okay, so we get to the bottom of this, right? So take 5 to 10 minutes break, okay? Okay, we are back. I don't know where I'm going with this. Okay, I just changed my Hawaiian shirt. It's also brand new shirt. Okay, so just to refresh myself. Uh, we need some another whiteboard. I'm sorry. It's taking longer, longer and longer and longer. Yeah. What whiteboard can we choose to erase? Yeah, this guy. Good. Very good. Okay. I need to refer back to this guy, so God bless us. Well, I can always buy another whiteboard from Walmart. It's $20 each. No biggie, okay, but let me open that window, it's hot. Yeah, I wash my face with cold Alaskan tap water, well based. By now it could be polluted with all the insecticide that's spread in my backyard. Yeah, I may die with cancer, whatever. Just kidding, okay, so. Alright. Let me just copy it down. Can we find some number where 2d plus 1 is equal to 2 times 10 to the third, a to the fourth plus b to the fourth. Okay, don't worry about this higher power, okay, because it will all dissolve and dissipate. 5 to the 2s and 2 to the 5, I like that, okay. So I was kind of looking forward to that. We equalize a and b to 1, okay, so no problem. We just need to find d. Alright, so we either prove it or disprove it, okay? Fermat's theorem builds conjecture, okay, so we don't know yet. Oh my goodness, my right shoulder is hurting, sore. Okay, let's say, comma, A and B is equal to 1, okay? This is A, squiggly A, period. Okay? This is left hand side. Okay? Left hand side. This guy is right hand side, okay? We don't know, we can find any d for that. Positive integer, okay? Now my right shoulder is hurting. Okay. Right hand side is 2 times 10 to the third times 2 plus 10, 5 to the second, 2 to the fifth, multiplied by 6, okay, plus 2 to the third, 3, 5, 26, plus 2 to the third times 126 plus 5 to the third. Is it an odd number? Yes. So we can find D. What is it? Let's calculate. 4,000, right? Plus. We'll do it by hand, okay? We're not gonna use any calculator and shit. We are old school, okay? No, we better use some calculator. I'm not gonna calculate all this crap. Where's my cell phone? I'm not gonna use calculator, okay? I mean, I'm not gonna do this by hand. I'll use calculator. Where's my calculator? My cell phone. Calculator, okay. 25 times 32 times 6 equals, okay, so this whole thing becomes to 448,000, okay, so 88 4,800 plus 4,000, 8,800, okay, so I'm gonna use some shortcut, okay, so you have to excuse me. Now, let me double check. I'm sorry. Okay, yeah, that's correct. Okay, so all right. 15 times 8 times. Can you see this? Yeah, we're doing this. Okay. 26. Okay, 3120. All right. Now, 8 times 126. 1008 plus 125. What the hell is that? Well, let's see. 8800 plus 3120 plus 1008 plus 125. What is it? 13053. Okay, so good app, nice calculator. And yeah, it's odd number. Okay, so what's D? Okay, let's divide by 2. Yeah, we don't have to use calculator for that shit. But we can double check, right? Okay. Divide by 2, okay? So 6, 5, 2, 6, multiply by 2 plus 1, okay? That's Euclidean division, okay? So let me double check. Yeah, good. So we found D. D is equal to 6526, okay? We may have disproved Euclid, not Euclid, but Fermat's theorem after all. We may have. I have to see. Okay. We may have found some counterexample for Fermat's conjecture. Okay. We may have. I don't know yet. What's the relationship between C and D? Do you have any past whiteboards? Otherwise, I have to do it all over again, dude. Ah, come on. I don't want to go down on the road again. C and D. Hey. We should find out C, okay? Boy. We may not have disproved it yet, okay? Because we have to conjoin A, B, C, D, okay? So, uh, we haven't quite, we are not there yet. We may prove it, disprove it, we don't know yet, okay? So, it's up in the air yet, by now, for now, okay? So, after all this, I'll share that with you, okay? Just bear it with me. Maybe ABC they don't quite jive very much with them. Okay, maybe we are not going anywhere. Okay, I don't know. I'm trying. Yeah, it's not quite working. Never mind. Ah, boy. Oh well. I think what we have done so far is confirming that Fermat's last theorem is correct. Okay, because that's what it seems. Okay, so yeah, I'm not disproving it. I'm kind of, in a way, ghetto, low down way, kind of confirming it. Okay, so looks like Fermat's last theorem is correct after all. Okay, I'm sorry to have disappointed you. I mean, in a way, I'm kind of glad because I didn't want to make all those mathematicians sad. Okay, so yeah, in a way, I'm glad. Okay, I did not disprove them and prove them to be foolish. So I'm glad I didn't do that. Okay, so but I want to make something out of this. Okay, so yeah, give me a second. All right. I'm so amateurish, right? Yeah, and I never claimed otherwise. Such an amateur, dilettante, dabbler. Yeah, I know. Hmm. I cannot make any counter example to Fermat's theorem. Okay, that's what I'm saying to tell you. I did try. I tried to break it. Okay, not to make a big name for myself, but it was kind of enticing. But I failed to do it. Okay, so I guess Fermat's theorem is correct indeed. Okay, and all those mathematicians, I guess they're right. Alright, so life's lesson, or not, whatever. I'm sorry if you are not following any of this. I'm sorry. Okay, I know it's all gibberish. Right? But I do want to discover something though, if not proof or disproof. I want to learn something out of all this. So that's why I'm continuing to think. Well, let me take a picture of this and then I have to erase this and write something new. Okay. All right. Smile. Okay. I'm going to erase all this. Okay. So well, not everything. I don't write all this down again. Uh, yeah, yeah, we can erase all this. Okay, so all right. And what's the worst that can happen? I have to write it all down again from this picture, copying it down. No problem. Okay, so okay, so we just use black. Okay, so we want to prove that it's not possible that 10a plus 1 so forth plus 10b. This black's shitty. This black I'm sure is better. 10 plus 5 so forth. We have to prove this cannot be equal to 10c plus 2 to the fourth. Okay, that's what we are trying to prove. This inequality. Okay, so we take 5 minutes break and I get more water, have some cigarette break, and we'll be back. Okay, so I'm having some problem. Okay, so it's not easy as I thought it would be. So we'll be back. Where are my glasses? Did I leave my glasses somewhere here? Ay. Okay, I got it. I also refreshed like 5 hours ago because I took a nap. Now I'm tired, hungry, sleepy. You know, there's this Thailand ramen noodle in Walmart. Uh, I bought it again because it was so good. Okay, it has three different kind of spices packaged. Oh, they're good. Okay, I'm sorry. I told you I found some hair. I think it was my hair. Okay, so it's not from them. I don't think. Okay, so probably it was my own hair. Just some ethnic joke. Okay, so the left hand side, right hand side, and we don't know whether this is unequal or not. Okay, we are going to prove. We are trying to prove this, and I'm having a lot of trouble proving this. Okay, so left hand side. Okay, it's very long. Right hand side is long too. We'll do it. Okay. Okay. The Pascal's triangle, right? 14641. Okay. So left hand side. Plus 5 to the fourth, and this is a 2b plus what? 2b plus 1 wrapped up in 5. Okay, alright. Leg work. That's left hand side, okay. Now, period, okay. Right hand side. This is what? 2 times 5c plus 1, right? So fourth. Open parent. My shoulder is sore. Okay, so, my goodness. Okay, we have to prove left and right, they cannot be equal, okay? we have to factor it out somehow to make it look kind of similar. Okay. Left hand side is even number. Right hand side is even number too. Oh well. We have to somehow prove that they are not equal. They cannot be equal. Okay, so that's our goal. Fuck this. Fuck this. Man. I don't want to do this, okay? I don't. I do not want to do this, alright? So, trust me. But, well, I got nothing better to do, so, okay? So, left hand side, okay? I don't believe I'm doing this, okay? So, 10 to the fourth, a to the fourth plus b to the fourth. Look like devil with this fork. Hey, ugly. So that's first term, okay? God, why did you have to make me do this? Okay, whatever. Second term, okay, so second term. What the hell am I doing? Stupid shit. Okay. All right, we got that. So laborious, minimum wage kind of. Hate doing this shit. Okay, 2 to the third times 3 times 5 to the second. Okay. A squared plus 5 to the 4th times 3 times 2 to the 3rd b squared, okay? Factor that. What's the common denominator? You have 3, 2 to the 3rd, okay, 2 to the 3rd times 3 times 5 to the second, okay, so 25 b squared, okay, so I hate doing this. Okay, so that's this guy. How about the other guy? Okay, so you have 2 to the third times 5a plus 5 to the fifth times 2 to the third b. Yeah, we find some pattern here. Silver lining, I guess, whatever. We'll try to fit in this one line, okay? Because we have to be very conservative. Save space. Right. Oh, well, we have a constant term, right? 5 to the fourth plus 1. Okay, so that's left hand side. Okay, so ugly, ugly, ugh. So ugly. Right hand side, we cannot simplify this anymore, right? So we just have to work with this. Okay, so can there be a, b, and c positive integer natural number that satisfy this left is equal to right? I don't know. Right? You just have to think about this. Yeah, let's do it. Okay, so right hand side. Okay, so 10 to the fourth 5 to the third 2 to the sixth c3 plus 2 to the fifth times 3 times 5 to the second. Okay, c squared plus 2 to the sixth times 5c plus 2 to the fourth. Okay, so that guy, this guy, and this guy, they correspond to each other. Okay, so this guy, square term and cubic term, okay, and the quartic term, okay. Well, that's that. Let's think about it. I would rather have dinner. By now, I didn't have breakfast. I didn't have lunch. By now, it's time for dinner, and it's time to cook. Okay, Thailand ramen noodle, which is fantastic. I just drank vodka, slept, drank vodka, slept. My breakfast and lunch is just been vodka. Okay, so which has some good calorie content. Okay, so that's why I'm not starving. I'm not too hungry now. Okay, can this two be the same? Can we find A, B, and C that satisfies this hypothetical equation? If we do, we found counterexample for Fermat's theorem, and we also to more general Bill's conjecture. Okay, and we can win $1 million. I mean, I can. Will I give it to you? No. Will I want that $1 million? No. Okay. I just tell Mr. Bill, Mr. Bill, thank you, but no thank you. I don't want all this. I have no time for your $1 million. No. I don't have time for that. Okay. So. Hey. Some mathematicians have proved this. Okay. It was easiest case in Fermat's last theorem, but I can't. I just cannot prove or disprove it. Okay, I cannot come up with example or counterexample. I cannot do anything about this. I just can't. All right, it's too much for me. I'm hyperventilating. Ah. Ooh. It's a difficult problem. I don't know how to do this. Okay, row algebra. I don't see any usefulness in this instance. Okay, I thought it would be because it had to do with periodicity. But I have to let it go. I'm sorry to fail you, but I just don't see it. I don't see how I can do this. Okay. Um, After all, I'm just amateur mathematician. Okay, so I just don't see it. Okay. Prove it, disprove it. I don't know how to do this. Okay. I tried. We do see some pattern though. Okay, we do. Power of five is always correspond to each other, right? But power of two, you start to deviate. Two to the five, two to the six, and two to the third, and then two to the five, and two to the third, two to the six. Difference one, two, three. We see that. We see that much. Five, 25, 125. Okay, so five to the fourth, five to the second, five to the third. We see that. But we are circling around, okay, because we want to prove a to the fourth plus b to the fourth is not, cannot be equal to c to the fourth. We are seeing it again here. We are circling around. Okay, so we are back to ground zero, square one, and I may have to let this go because I'm not getting anywhere. is too difficult for me. Okay, I hate to give up, but I'm not seeing any light at the end of the tunnel. Do you? I'm sorry. I just don't. Yeah, I want you to challenge all these gigantic mathematicians. You want to prove them wrong, but I just don't see it. This power operator is too powerful for me. Okay, it's too much. What if we subtract this two? What would it look like? We subtract left and right, okay? We may want to explore that possibility. Okay, so as just curious, all right? Let's try that. Okay. I'm just out of curiosity. Okay, left minus right, right. Okay, so that's 10 to the fourth. Out of curiosity. Okay, out of curiosity. Okay, you have two to the zero, two to the fourth, two to the second, two to the third, and you have C4, C3, C2, C1. So adding them together, it was end up becoming four. Okay, we do see some pattern here. Okay, so we are not sure it's gonna help us or not. We just noticed some pattern. Okay, so can this be zero? What is C, by the way? Is this some arbitrary number, or do we have some constraints, some imposition of rules regarding C. I don't think there is. Okay, I think C, A, B, C, they're just arbitrary numbers. All right. C is the only term with the negative. Okay, so all right. Oh. Mm. Well, five to the fourth plus one minus two to the fourth. That's positive number. So that means uh, everything except this constant term, everything that involves A, B, and C, it has to be some negative number, right? We know that much. Okay. So A, B, and C, that's one or more. So um, or not. I don't know. Okay. So difficult problem, really, very difficult. Yeah, I don't think politics is any easier than mathematics because you may have very good ideas. I mean, I do have many good ideas to solve the world problems, save the world, but I'm not there. To get there, to be the president or governor, congressman, senator, that's whole another story. You know, it's not easy to get there in the position of power. Yeah, so politics, mathematics, I don't think they are easier than the other. I think they are both very difficult problems. Okay, so all these people who become governors, senators, congressmen, president, they got there, but they don't have a clue how to solve the problems. And people like us, with all the solutions, we don't get there. So world does not get saved because people up there, they don't have a clue, they don't have a solution. People down there like you and me, we have all the solutions, but we are not there. Okay, so alas, right? Mathematics, yeah, is as difficult as politics. Okay, so just some observation. Okay, so boy, I don't have a clue, really, honestly. You know how hard I worked, right? But I don't have a single clue how to go about this. I don't. Okay, just a little idea, just small idea. Okay, so we know the terms containing A, B, and C. It summation of that has to be negative because the constant term here is positive. Okay, so for this to be equal to zero, right? Okay, let's say A, B, and C they are one, one, one. All right, and this become positive, 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 positive. Okay, so A, B, and C they cannot be one, one, one. Okay, how about A and B are one and C is two? Okay, negative 2 minus what 1 1 2. Okay, it cannot be 1 1 1 because then it become over positive. Okay, 1 1 2. Okay, so 2 minus 2 to the fourth, 6 minus 2 to the fourth, 1 1 2. Okay, 26 minus 2 to the fourth, 126 minus 2 to the fourth. Okay, so negative negative positive positive. Okay, so what's this number, by the way? 625 plus 1 minus 16. What's that? 15, 610. Okay. Can we find A, B, and C such that it becomes negative 610? Okay, so that's our question. You know, I have to fold this up because I'm just tired. I'm too hungry, sleepy. Okay, famous last theorem. We went at it. Okay, we went after it. Build theorem, $1 million, but I'm not getting anywhere. Okay, so we may have to get back to this later. Okay, but for now, I don't see any light at the end of the tunnel. So what would I do? I will pick another tunnel. Okay, easier tunnel to get through. This tunnel. What did Jesus say? He said, "Oh, there's a big army coming at you, and you don't have that many soldiers with you." So a smart person would do what that's what Jesus said. A smart person would do make a deal with that bigger army than your army when he's still far away. Yeah, make a deal, apologize, so that you don't go into war with this bigger army. Okay, because you have to be realistic, pragmatic. That's what Jesus said. Okay, so we take Jesus' advice and yeah, I'm sorry for giving up, but I it's bigger than what I can handle. Okay, so I'm sorry. Okay, so I'll see you tomorrow. Good night. Bye.